So this is still lesson 8.1, subtracting polynomials. So most of what we talked about yesterday gets repeated today. You're going to deal with the polynomials in standard form, decreasing degree order. You are going to be combining like terms. The trick in this one is what happens with subtraction. Okay, so we're going to go through an example, and we're going to write down one thing, and this is what you should remember from dealing with integers, is that to subtract means the same as adding the opposite / additive inverse. So when I add inverses or opposites, that is the same thing as subtracting. Okay, so that's the key thing I need you guys to remember. So what happens is, I'll do a real simple example here. Let's say we have x squared minus 3, and I want to subtract from that x squared plus 2x plus 4. So this also brings up the property distributive, because basically when I'm doing subtraction, I want to add the opposite. I'm adding the opposite of every term that comes after the subtraction sign. So basically what happens is this. Subtraction becomes addition, and each of these signs change. That's the key, is to remember to change all of the signs of the second polynomial, because it's what comes after the subtraction sign. All right? Now I'm going to give you two different problems because they sometimes give you the question already vertically, and a lot of kids make mistakes because of the way that it's written. So I'm going to make sure that we don't have that issue. So let's do just a couple examples of these, and then we'll be done with our notes for today. So let's start with a problem that looks like what you did yesterday, and that's where we've got our two polynomials like this one written horizontally. Directions are just going to ask us to find each difference. So we've got 3 minus 2x plus 2x squared, and the second polynomial that we're subtracting is going to be 4x minus 5 plus 3x squared. So yesterday we had the ability to choose whichever polynomial we wanted to go on top, and then we just kind of matched up underneath it. When it's a subtraction problem, we don't get that luxury. What we should do is just the first polynomial we see is the one that's going to go on top. So what I'm going to do is take the first polynomial and rewrite it in standard form. I'm going to take first poly and rewrite in standard form. Now, if it's already in standard form, you're not going to need to do that. Okay, so this one would become 2x squared minus 2x plus 3. Now, before I can start picking terms and moving them, I'm going to have to find the additive inverse of the second polynomial. So we're going to do the additive inverse of second polynomial, so second poly, and I'm going to say change all signs. That's really what it's all about. So this is now going to become addition. This is negative, this becomes positive, this becomes negative. Okay? Now I'm going to start lining up like terms. So now the rest of it is just like what we did yesterday. So I'm going to take the negative 3x squared, pairing up with the 2x squared. I'm going to take the negative 4x and pair it up with the negative 2x. I'm going to take the positive 5 and pair it up with the positive 3. And now all we have is a addition problem. So signs are different on my x squareds. Bigger number's negative, so my remainder's negative, and 3 take away 2 is 1, so I just write negative x squared. Next to the x's, they have the same sign, so I'm going to add, and I get negative 6x. And then in my constants, they are also same sign, so I'm going to add, and I get positive 8. So the trinomial answer is negative x squared minus 6x plus 8. Okay? So let me show you a horizontal version, or a vertical version, and this is the problem that I see people run into. So on this one, it's going to be given to you already looking like it's set up to solve. So we've got 4p cubed plus, now I don't know why they do this. Oh, never mind, I get it. Here, let me start back from something else. We've got, I'm going to do this a different way. 4p plus 7p plus 4p cubed minus 8. And I'm going to subtract from this the 3p squared plus 2 minus 9p. So to rewrite this again, we're going to start with the first polynomial is going to go on top. Now, if you notice, I have an exponent of 1, an exponent of 3, no exponent. So I'm skipping an exponent of 2. So we can, and we talked yesterday about that, is that we can hold the place. And they use 0p squared, which would equal 0. And you could just use a 0 to hold that spot if you wanted to. You don't have to put the p squared. But again, they're trying to get you to understand there's a spot for that other guy to go. Okay? Then we have the 7p and then the minus 8. Now, the problem looks like this. Now I'm going to rearrange these, and we have 3p squared minus 9p plus 2. The issue is we haven't taken the additive inverse of the second polynomial. That's, and sometimes they'll give you the problem already written like that. We still need to distribute. This has not done its job yet. So we're going to need to make sure that we're distributing the negative to that positive 3p squared, that negative to that negative 9p, and that negative to that positive 2. So we still have to change the signs. So the actual problem we're going to be solving is this. 4p cubed plus 0p squared plus 7p minus 8. And now it's become an adding problem because I've changed the individual signs of the second polynomial. So I have a negative 3p squared, a positive 9p, and a negative 2. And then I go ahead and add. So 4p squared has nothing, so he just comes down. Here I have a negative 3p squared being added to nothing, so I get negative 3p squared. Here on the p's I have same sign, so I add and I get 16p. And then I have the same sign on my constants and I get a negative 10. Okay? Would you like to see another example, or are we good? Brandon?
Wait, I'm sorry, why did you put the 0p squared again?
Because I noticed that the first term skipped exponents and went from 1 to 3 to none. So there was no second exponent, right? No power 2. And the second polynomial had a power of 2, a power of 1, power of none. So if I didn't leave a gap, I'd be somehow trying to squash in that 3p squared in between the 4p cubed and the 7p. So when you're missing an exponent, you're not in exact descending degree order 3, 2, 1, 0. You put in a 0 or put in a 0p squared to hold that spot. Okay? So again, it's just like when you're doing multiplication and you have to put that 0 in, or that x, I think your teachers would teach you in elementary school to hold that spot when you're multiplying by the 10 value. so that you line everything up properly. And it's the same idea. You just want to make sure that every possible term has a spot. Okay? Michael? It is a placeholder, exactly. So again, you don't have to write 0p squared as far as I'm concerned.
Oh, no.
You could just write 0 for that one. Okay?
And then you put the 3p squared on it.
The negative 3p squared would go underneath, because that's his order that it would go in, right? Because we're looking for standard form. 3, 2, 1, none. Okay? You need another example? Yes? No? No? Okay. All right. That's it.